So the next strategy, call it strategy B. We are now going to look at odd powers of the sine. So here we had odd power of the cosine, and here we have odd power of the sine. So we are looking at m equals 2k plus 1, and k is 0 to 1, 2, and so on. What we want to do in this case is factor sine theta to get sine theta d theta. So pretty much the same idea, except different differential at the end. So let's see how this works out. We start with our integral I, as before, will be the integral of sine theta to the n power, cosine theta to the n power d theta, and we know that m equals 2k plus 1, so we can skip, we can follow the same idea and say this will be the sine of theta squared to the power of k. So we have 2k here, right? And we have one more sine theta, which we want to factor. And then we have the cosine theta to the n power d theta. So I have 1 and 1. So this will be what I'm looking at. Now I need to convert the sine, write it in terms of the cosine. Okay? So I'll use the substitution here, sine squared equal 1 minus cosine squared, like so. The integral now going to look like this. After a little rearrangement, it will be 1 minus cosine squared raised to the k power, and then stick the cosine to the power to the nth power, and then we have sine theta d theta. Now, the substitution will be such that we're going to have u equal cosine theta, and therefore du equals negative sine theta d theta. Okay? Many.
So this is pretty much the same exact thing as strategy A, except we have sine cosine.
Right. The difference between A and B, strategy A and strategy B, is where is the odd power? In A, we're looking at the odd power being the power of the cosine. In B, the same thing, except the odd power is the power of the sine. The third case will be no odd powers at all. Both powers are even. And that would be strategy C, which comes next. Okay? And by that, we cover all the options. So let's now let u equal cosine theta and du equals negative sine theta d theta. Okay? Or, of course, sine theta d theta will be replaced by negative du. Okay? So I, after performing this substitution, I will be the integral of 1 minus u squared raised to the k power, u raised to the nth power, and instead of sine theta d theta, we have negative du. And we can finish this up by saying this is the negative integral of 1 minus u squared to the k, u to the n, du. And if what you like is a recipe and you want to memorize this, then this is what you need to memorize. If you don't like a recipe and you want to use the